So here we go. Section 1 of Unit 5. Unit 5, students often ask, why don't we learn like practical things like doing taxes and balancing checkbooks? This is maybe the most practical and direct of our units. Statistics show up all the time. Again, it's anytime it's in a commercial where it's 4 out of 5 dentists recommend whatever, or again, this percent of the population does this. Those are all statistics. So we're going to talk a little bit about how those statistics get developed. How do they find those numbers? And again, you have the option next year of taking a full year of statistics. Typically, again, your path goes, you can either do advanced math, which opens up some more possibilities, or you can do statistics, a little bit easier, a little bit more directly applicable like this. Pretty much if you go to college though, you're going to take a statistics course. It'll depend kind of on which major you choose, which statistics course you take, but almost everybody takes the statistics class in college, whether you're doing a 2-year associate's degree or a bachelor's degree. So this is a little bit of a preview of that. So again, they talk about where do approval ratings come from, how do they come up with all these different statistics? Well, typically, they're coming from a sample, which is a small part of the entire population. Anybody know how many people there are in the United States right now? Roughly. Close. I think it's like between 300 and 400 million. I haven't checked recently. I think it's like 330. I don't know. I'd have to look. But over 300 million. There is no way, there's no conceivable, simple way of asking all 300 million people a question and getting an answer. So typically we take a sample, whether that's like 10,000 people, which is still a lot, it's still going to take a long time to gather or more. But then the idea is that that sample is supposed to represent the entire population, everybody. So everybody understand the difference between those two, that the population is everyone, whether if it's a population of the United States, population of our school, that's everybody in that group. And the sample is a small subset of that you're asking the questions of. So you guys right now, you are a sample of Clovis East High School. Now, you guys are a biased sample of Clovis East High School because you don't represent the whole high school, right? We don't have any freshmen in here. We've got some sophomores. It's mostly juniors. We've got some seniors. Does that make sense? So this class is biased towards juniors because there's mostly juniors in here. So any question I ask, I'm going to get more information from juniors than I am from the other classes. Sometimes that doesn't matter. Sometimes it does. If I'm asking you guys like, okay, where should we spend our money for the school budget as far as activities? Well, some of you maybe like formal or the prom or something like that. Whereas the freshmen are like, I can't even go. Why are you spending money on that? So it's going to like there's going to be different answers depending on who I'm asking the question of. And that's what we call bias. So again, when you have a sample that favors a particular part of the population, that's a bias. The goal for gathering samples is to get one that actually represents the whole population as equally as possible. Now we're going to talk about 2 different facets of statistics today. We're going to talk about first study types, okay? There's 3 types of studies that we're going to be talking about. There's more. We're just talking about 3 of them in our unit here. The first one is observation, and it's exactly what it sounds like. An observation is where you gather data by observing or by kind of seeing what's already happening. So gathering data by observing, kind of watching, recording what's happening already. Now, this often does require you to do something like, okay, if I go to the beach and I gather up trash on the beach and see, okay, what kinds of trash are on the beach? That's an observation, but I'm still having to go around and gather stuff. Does that make sense? I'm still having to do work. If I go out and I take tree core samples or like dirt samples, I'm going around collecting stuff from different places. That's still observation because I'm not impacting anything. I'm just collecting it. Does that make sense to everybody? Now, experiments, this is typically what you think of when you're in your head thinking of someone doing some kind of study. An experiment is where you are changing one particular variable and recording what happens. So So you're changing something. Now, technically, you could change more than one variable, but that's typically a bad method for gathering information. We want to change one thing and record the results. How many of you have heard of control groups in samples? About half of you, a little bit more. So a control group, again, is one group that you set aside and you don't mess with them. You leave them alone and you compare their results to whatever you're experimenting on. So you're in a control group, you leave them alone, you compare them to the rest of the group, whatever you're experimenting on, to see if there's a difference. You don't have to have a control group for an experiment, right? I could just split the population up and experiment on all of them, but that's usually not the best way of doing an experiment. Oftentimes, you really want to have one variable that you're changing and then have one control group to kind of compare against. If you guys have been following the news at all during the last 2 years, again, you're hearing all the statistics about COVID vaccinations and things like that. And they'll often talk about during the initial amount, they're doing a trial. And there's a certain number of people that are in the trial. And then usually like half of them get the vaccine, half of them get a placebo, right? That's the placebo is the control group. And then you see, okay, how many people in the control group get sick? How many people in the vaccinated group get sick? Is there a difference? And that's how they figure out, okay, it's 91% effective or whatever, by looking at that difference between those two groups. Does that make sense to everybody? So now we have a third type, a survey. The survey is literally asking people questions and recording their answers. So you write down something that makes sense to you, and I'll put an example up there and just call it. Yeah. Oh, okay. Finding the language, or okay. I will send them right now. Bye. I don't know what's going on there, but they said that they're expecting to migrate. So when you think about that migrate, then I don't really know. All right, so let's see here. For the survey, and I already did record this one, I'll record this also, so you'll be able to watch one of those and get caught up. The survey is literally asking questions and recording answers. Now, these are not like exact definitions. As long as you get the idea, it's fine. Here, I can show you what we did last year. See if how close I am to what I did last year. Observation, observe and record what's happening. Experiment, design an experiment to test one particular case, often with a control group. Control group is left alone to compare with the experiment group. And then asking questions and recording answers, right? Anything that follows kind of those three definitions is going to be just fine here. Does everybody understand the difference between those three? So that's what we're going to try out now. We're going to look at some examples and see if we can figure out which of these is going to be best for this particular case. So like the first one, a few geologists from a university located in California would like to determine the time gaps between major droughts that the West Coast has experienced. Which method are we going to use to figure out how often we get droughts? You guys think observation, right? It's not experiments. I can't control the weather. I can't adjust things and see whether it makes a drought or not. So, and I could do a survey. I could go around asking people, hey, do you remember the last drought? But that's going to be unreliable. Does that make sense? And it's only going to go back so long. So best case here would be gathering data from what's already out there. Now they already do just gather and record data about rainfall. I don't know if any of you were paying attention to the news about a month ago or so. They were talking about how that big rainstorm that we got broke a bunch of records because they've been recording rainfall for the last like over 100 years. And that one storm had more rain than Sacramento or San Francisco have seen in a day in like over 100 years. Now, it wasn't enough to end our drought because one day of rain helps, but there's still a lot that we've got to build up. But it's interesting that they've been recording that for that long, and we have the most rain in one day. So that would be all observation here. You could also do observation with tree core samples. And again, measuring growth rings. That's one of the ways they try to track droughts and periods of rain. Trees grow more when there's more water. So smaller growth rings, less water, more likely to be a drought. But that's still just observation. So no matter how they choose to do it, we're looking at observation. Now, you can either describe why the other ones don't work or why that one does work. So you can say observation, can't experiment with the weather, and survey would be unreliable. Something like that would be fine. You're kind of saying, okay, why don't the other ones work? Or you could explain why survey works best. Next one, senior class at a local high school is deciding which of the 3 possible speeches is going to be delivered at the graduation ceremony. What do you guys think? Which method should they use to figure that out? Survey, right? You ask everybody which kind of speech, who do you want to come speak at your graduation? So an experiment would require like giving all 3 and seeing what how people react. I don't even know what you would do. Well, yeah, so that would be the experimental, and then observation would just kind of be like watching what happens in other speeches. It just doesn't make sense to do the other ones. Survey is going to be the easiest to do. So let's say survey, ask students which speech they would prefer to hear. Anything like that. Major lawn care company is attempting to develop a new fertilizer that promotes a certain type of lawn to grow healthy at an accelerated rate. What are they going to do? An experiment, right? You get a bunch of grass, you put fertilizer on one, not on the other one, and see what the difference is. Again, you don't have to put exactly what I'm writing down, anything along that general idea that there's doing an experiment, they're trying the fertilizer on one set of grass, not on another, and seeing what the difference is. Letter D, an international bike company has developed a new way to weave carbon fiber to make their bike frame stronger and lighter. Bike company already has the strongest and lightest bike frame on the market. What are they going to do? How are they going to show that their new bike is better than the old one? This one's a little bit harder. I heard a few different things. I think I heard mostly survey and experiment. The issue with survey is that they would have to sell the new one and then ask people how it's doing. And that could cause problems, right? If you release a whole bunch of bikes and everybody's complaining, oh, they break all the time, you're going to get a bunch of unhappy customers. So survey's probably not best here. Probably an experiment would be better. Take the new bike frame, bend it until it breaks. Take the old one, do the same thing, and measure the difference. Like, does it withstand more? Is it lighter? You're still kind of comparing those two. Now, okay, you could do an argument for observation. You would say, okay, well, they already made the bike frames and they're just going to test them and observe. But really, if they're developing the new one, they have control over that. I would say that's more of an experiment. Does that make sense? If they're adjusting the parameters, trying out the new method. But you could argue either one. There is some ambiguity here. You just have to be able to explain your answer. So I'm going to say experiment here. Again, you could put observation as long as you explain it. Survey is probably not a good way of doing this one. A little bigger. There we go. So I'd say experiment. Test the new bike frame and compare with results of the old bike frame. Or test the old and new bike frames and see how they're different. Does that make sense? Again, you could use kind of the same idea for observation. It depends on how you're going to explain that. Last one, Gallup poll. How many of you have heard of the Gallup poll? Anybody? Shows up in the news every once in a while. There's different companies and groups that do these kinds of surveys and experiment, or I'm just giving away part of this one, surveys to gather data and then publish those results in the news, in research studies, things like that. So if you watch, the Gallup poll is one that comes up a decent amount. If they want to know the percent of people that are going to vote in the next presidential election, what's the best way to find that out? Ask the people, survey. Does that make sense to everybody? You send out mail, you call up and say, hey, are you planning on voting in the next election? And record the results. Now, they could sit outside the voting places and record how many people do vote, but you see that that's not what's going to come up in the future. That's what's happening right now. It's going to be after the fact. And that's not what they're asking here. That would be an observation, and it would be a way of showing who did vote or how many people did vote in the election. That doesn't work for figuring out who's going to vote. You actually have to ask. Do you guys all feel like you have a good understanding of the different types of, and we're calling these, again, study methods? Everybody's good with the difference in 3 types of study methods. Now, the trick is, don't confuse those with our types of sampling methods. So go to the next page. Now let's talk about sampling methods. A sampling method is, how do you get your data from that particular sample? Stratified means you break the population up into groups and then get a sample from each group. So again, pretty much every time we're talking about high school and we're saying, okay, we're doing freshmen, sophomores, juniors, seniors, 50 freshmen, 50 sophomores, 50 juniors, 50 seniors. That's stratified. You broke them up into groups and you took a sample from each group. They'll do the same thing oftentimes with like the general population. So they'll say, okay, people ages 0 to 20, people ages 21 to 49, people ages 50 to 59, 69. Breaking it up into groups that way would be stratified. Breaking it up into male, female would also be stratified. Anything like that, where you break, or income amount. So like you break the groups up into, if you make less than $50,000 a year, make $50,000 to $100,000 a year, $100,000 to $150,000. If you're breaking the groups up and then getting your samples from each group, that's stratified. Does that idea make sense to everybody? Systematic then is using a system, a pattern to pick your sample. Anytime you see a specific pattern happening with how they're gathering it, it's going to be systematic. Every 10th person, every 100th person. That is a systematic approach, a systematic sample method. Whereas simple random sample, a simple random sample means getting random group or random individuals out of the entire population. So selecting randomly from the entire population. Typically, you're going to use like a computer program or a calculator or a set of random numbers to generate the randomness. So again, you'll often see them referred to like using a software program to pick randomly, or they used to have like just giant books of random numbers. You like go to a random page, pick a number, and then go from there. That would be your random pick or your random number generator. There has to be something that makes it random. Does that make sense? Standing somewhere and just saying that one, that one, that one, that one, that's not actually random. Does that make sense? There has to be some way of actually mixing everything up. Even these things, popsicle sticks with your names on it. This is random. Does that make sense? More so than me just saying, oh, you, and you. Does that make sense? That's not actually random. There might be, again, people sitting in a certain area. I might pick more often. This would help randomize it. Names in a hat, assigning numbers to people, and then picking randomly. Using, again, a computer program. Anything like that is going to make it more random than what we might typically think of as picking randomly. There's got to be some method for actually making that randomness happen. Self-selected is literally individuals volunteer to be a part of the study. So self-selected only works when you're sampling from people. Does that make sense? I can't go out to the woods and take tree core samples from a self-selected sample because the trees can't choose to be a part of it. Sometimes people get confused and they think, oh, well, you're picking the individuals or the sample. That's not self-selected. Self-selected, they have to say, I want to be a part of it. So this is when you see the ads on websites that say, your voice needs to be heard. Click here to put in your input. You're volunteering by clicking that ad. Does that make sense? Or the ones like that are posted on the sides of like a telephone pole or in the hallway saying, if you want to be a part of this, this survey, call this number. Those are all self-selected. You are choosing to be a part of it. It only works if it's people. Convenience then. Convenience is whatever is easiest. Picking a sample based on what is easy. Convenient. If I'm taking a sample of the whole school and I ask you guys, you are my convenient sample because I've got you all here right now. Does that make sense? Those last two, self-selected and convenience, are almost never fair as far as they're almost always biased. Anybody want to take a stab at why self-selected is almost always biased? This is the one that's the most obvious for students usually. Self-selected is almost always the people that are interested in whatever the survey is. So if we're surveying the school and like, okay, if we hire a band for the next bands, who do you want to hear? It's going to be the people that are most interested in the music. Does that make sense? The ones that are just going to be going along because they want to hang out with friends may not participate. Or if it's something that is an interest area of yours, whether it's about sports or about club activities, things like that, the people that are the most invested or the most interested in it are going to be the ones that are most likely to participate. Whereas the people that don't really care or have mild feelings about it may not choose to go out of their way and help out or volunteer their information. And so you're going to get a biased sample there. You're going to get more people that care about it, less that are ambivalent. And convenience is often biased because you're getting just whatever is nearby. Does that make sense? It's not a good sample of the whole school, or again, whatever the population is. If I walk out into the forest, pick a random spot, and then sample the 20 trees closest to me, that's not going to be a very fair sample of the forest because I'm only getting the ones in that particular area. Does that make sense? The environment might be different than just a little bit farther on. Anything that makes you get more of one type or one group out of the population is going to be biased. So let's see if we can go through these. John was walking through the campus, asked people to volunteer themselves to be a part of his research, did his best to make sure that the number of students he selected from the freshman class was equal to the other classes as well. So he's trying not to underrepresent the freshmen. But what's the most important part of this description? The volunteer. Does that make sense to everybody? This is going to be a self-selected sample. And it's going to be biased because people are choosing to be a part of it. And typically the ones that are interested are the ones that are going to participate. Actually, it's not necessarily only, but the people that are interested will be more likely to volunteer. There's even a little bit of an issue. It looks like he's kind of trying to go for stratified, right? Trying to be careful that he gets enough freshmen. But if he's not actually doing stratified, that can actually make things more biased if he's watching for freshmen to try to ask questions up. All right, Frito-Lay makes a product called Doritos, produced in a factory. Quality inspector of the factory would like to collect a few of the bags produced by the factory to see if the weight of the bag meets the specified amount acceptable to Frito-Lay. Right, if it's the bag say 6 ounces and they're putting in 7 or 8 ounces, Frito-Lay is losing money. But if it's 4 or 5 ounces, they can get sued for mislabeling stuff. Does that make sense? So they want to make sure it's accurate. So they're going to do an inspection. The inspector took the next 50 bags off the conveyor belt to inspect. What did he do? I heard a couple different things. Convenience is best here because it was easy. Does that make sense? It's kind of random as far as it's whichever happened to be there, but it's not actually simple random because there's no randomness. He's not introducing randomness. He's not like lining them all up and then using a program to pick the random bags that he's sampling. Literally just the next 50 that come off. Why could that be biased? Just think. What happens if someone's not paying attention and they accidentally like hit the wrong speed on the conveyor belt, or there's a malfunction and all of a sudden a bunch of like extra chips get dumped into some bags? Is it more likely that the ones he grabs are all kind of the same type? Does that make sense? Because they're all right next to each other. And so we're going to say this is convenience. And it's going to be biased because the 50 bags were all near each other, made at the same time, and are likely to all be similar. Does that make sense? The 50 that he picks are likely to be more like each other than they are like the whole population. Letter C, Raul obtained an alphabetical list of everyone at the school, numbered them, 1 for A, all the way down to Z, then got a list of random digits, used it to obtain his sample. What kind of sampling method is he using? What do you think? What kind of method is he using? Simple random sample. Does that make sense? He has a tool that he's using to generate that randomness. He's picking from the whole population. And we're going to call this one potentially unbiased. If he does it right, there's a good chance that he's getting a pretty fair sample of the whole school. Now, It could be biased if he wants to make guesses about the whole population of his city or the state or the country. Does that make sense? Because he's only going to get, what, 14 to 18-year-olds? So it depends on what he's looking for. If he wants a sample of the school, this is pretty good. If he wants a sample of something bigger than that, he may have a problem. Now, the reason it's potentially unbiased is everyone is equally likely to be a part of the sample. And that's what we aim for, right? That everyone is equally represented. And every group is equally represented or proportionally represented. All right, letter D. Maureen divided her school up into 4 groups: freshmen, sophomore, juniors, seniors, listed everyone in the class, numbered them. After that, she randomly selected students from each class using some computer software. Selected students then represented the school. This one has aspects of 2, but which is the overall category, the type of sample that they're using? Stratified. Does that make sense? Overall, it's stratified. Stratified always goes with another sampling method, because once you group everybody, you still have to pick the samples. So if you want to go for bonus points here, you can call it stratified with simple random sample. But the important part here is stratified. That's what I'm going to look for. Again, potentially unbiased. Got to put the LY on this one. Again, looks like they're doing a pretty good job of equally representing everything. Now, this would be a problem if you don't want to represent each class equally. If there's a reason, if it's the senior trip, why are you asking freshmen, sophomores, juniors? Does that make sense? But if you want a good sample of the whole school, you want to make sure that you get somebody from each class, because each class could have different opinions. It's probably pretty good. Last one, math teacher wanted to select a sample of students based upon 2 periods of math 3 classes. Instructor numbered each student, starting with 1, ending with 70. Teacher then decided to use every 10th person, wherever they started. So the teacher uses a calculator to randomly select the value 45. So put it in, pick a random number, picks 45. At that point, teacher counted down the list every 10th person. So 45, 55, 65, all the way through, maybe start back at the top, keep going. Every 10th person is added to the sample. Which sampling method is this? Does everybody see the pattern? Right, every 10th person, this is systematic. Now, some people get thrown off by the fact that there's that randomness at the beginning. But does everybody see that it's not random every time? The randomness gets us started, then the pattern takes over. And so that makes this, again, systematic. Now, this one's really going to depend on what kind of population we're looking for. If we want the population to be all math 3 classes, maybe it's okay. If the population is the school, that's probably going to be biased. Like we talked about the fact that most math 3 classes are going to feature more heavily juniors. So it depends. Biased, if we are looking at the whole school. Math 3 classes would be biased towards juniors. Potentially unbiased if we are looking just at math 3 students. Something along those lines. Does everybody think they understand the differences between the, sorry, I can't slide it up anymore because that was the last part. The differences between those different sampling methods? You guys need to be careful that you distinguish between sampling method and study method. Does that make sense? So let's look at the homework here. The homework for tonight is going to be 1 through 21. You've got about 15 minutes, a little bit more, to get a good chunk of it done right now. So if I'm looking here at the homework, numbers 1 through 6, identify the sampling method and then the bias associated with it. So you're going to look at this and use a sampling method. That's simple random, stratified, self-selected. Those would all be sampling methods. So the very first one, manager of Save Mart wants to find the percent of shoppers who bring their own bags. Interviews every shopper that enters the produce section. What method would that be? Convenience, right? It's just staking out one spot and taking everybody that comes by. Why could that be biased? Go ahead, Emily. Right. Not everybody's going to go to the produce section. And you might have a certain type of person that's more likely to go to get produce than people that don't go get produce. Does that make sense? Might get more health conscious people, maybe people with a little bit more money because they're buying fresh stuff instead of canned things. That's going to be biased. So that's what I'm looking for here. Sampling method and a type of bias. Number 7 is just a description. 8 through 10 are the study methods. So 8 through 10, we're looking at experimentation or observation. Or what was our third type? Experimentation, observation, and survey. So 8 through 10, I don't want to see simple random sample as an answer for 8 through 10. And then you're going to decide, okay, is that sample going to be a good representation of the population? Again, kind of like, is it biased? Another description of that. 11 through 14. 11 through 14, a question is biased if it pushes you towards a particular answer. If I tell you guys, or if I ask you, don't you agree that Justin Bieber is the best artist ever? Is that pushing you towards a specific answer? As opposed to saying, who's your favorite artist? Or who's your favorite musician? That's a more unbiased question. Does that make sense? So you're going to look at each of these and decide, okay, is that a fair question? And then you can also try to answer the others. What does it mean to have an unbiased sample? Is a large sample or a small sample better at giving a good idea of the population? So you're answering those. And then 15 through 18, you're picking one of these, convenient, self-selected, systematic, or random. They don't have stratified on here. And deciding the sample obtained would be, which one would be best? And then would the sample that you got be unbiased or biased, and explain. And the last couple, answer the following. So the idea is do your best through those questions. I'm going to give you, again, you got about 10 minutes at this point. Get a good chunk of them done right now. Ask any questions you've got. If you're stuck, let me know. I'll try to pass back some of your old work as well. So again, 1 through 21 is what we're trying to do here.